I want to find the rate of change when x is equal to p, at point P. So the only thing that we can do, because you can't find the slope of a curve, you can't find the slope of a line, excuse me, with only one single point given. So with this concept or this idea, we're going to pick another point, going to call it Q, thus giving me a secant line. This line right here is my secant line. Now I want point Q to be really close to point P. And then I'm going to let point Q approach point P, which is just another way of saying we're going to let the value of h get smaller and smaller and smaller. Because eventually the slope of my secant line will be equal to the slope of the tangent line. And that's what I want to find, is the slope of this tangent line. Because that will give me, well, slope, rate of change, they're the same. That will give me the rate of change at that particular point. So if I begin by looking at the slope of the secant line, change in y over change in x, I'm going to have f line, and then find the limiting value as you allow h to approach 0. What you find is the slope of the tangent line. What's a slope? A slope is a rate of change. You've just found the rate of change at the instant x equals -1. But we call it finding the slope of the tangent line. But more importantly, what you have done is you have found the instantaneous rate of change at x equals -1. And of course, we'll always say, well, if you know the slope of the tangent line, you might as well go ahead and find the equation of it. So I've got slope is equal to -2. When x is equal to -1, what's the corresponding value of y? Because in order to write the equation of any line, two things you got to know. You have to have the slope of the line, and you have to have a point that the slope or that the line passes through. Well, I got the slope, I got the x coordinate of the point, all I need is the y coordinate of that point. So if x is equal to -1, y has got to be equal to 2. I'm hearing 3s, I'm hearing 2s. Right there it says y equal x squared plus 2. -1 squared plus 2 is 3. There you go. Write the equation of a line with a given slope and a point that the line passes through. Point slope form, I've got y minus 3 equals -2 times x plus 1. And there's the equation of your tangent line. Please note, just leave it in point slope form. You've always been bombarded in your algebra class, oh, it's got to be in slope intercept form. Solve for y. No, you might screw it up. Don't take that chance. Stop right there. That is perfectly acceptable by the College Board. And that gives us the equation of our tangent line. Then, of course, they say, well, we want you to maybe look at the graph of it. Well, then you'd have to take this equation and put it into slope-intercept form, y equal -2x plus 1. But to make a long story short, I have the parent graph y equal x squared, and I add 2 to it. What transformation has occurred when I add 2 to the parent graph of all quadratics, y equal x squared? Say again? It goes up 2 units. Okay. So it'll go up 2 units. And then if I graph this line, I have a y-intercept of 1 with a slope, so we're looking here That's what the graph would look like if you actually took the time with your grapher, we'll call it, to come up with that. That's such a cool problem. Instantaneous rates of change. So to make it official, it looks like this. The slope of a curve at a point. The slope of a curve, y equal f of x, at a point is the number where the slope equals the limit as h approaches 0 of f of x plus h minus f of x, all of that divided by h. Yeah, a curve can have a slope. Until now, you always thought the only thing that have a slope is a straight line. Nope, curves can have a slope because a curve can have an instantaneous rate of change at any given point on that curve. We also inform you that the tangent line to a curve at a point we'll call P, of course, is the line through point P with this given slope. Slope of a curve. Slope of y equal f of x. The slope of a curve, number one, means the slope of the function at some given point. Number two, the slope of the tangent to the curve y equal f of x at x equal a. Number three, the instantaneous rate of change of the function f of x with respect to the variable x at x equal a. Or we can simply say the limit as h approaches 0 of f of x plus h minus f of x divided all by h. All four of these statements mean the exact same thing. Sometimes if we are asking you for the instantaneous rate of change we won't flat out ask you what is the instantaneous rate of change of this function at this point. We might simply ask you, find the slope of this function at that given point. Or we might simply ask you, find the slope of a line tangent to the function y equal f of x at x equal a. Or sometimes we'll just really be nice to you and say, okay, find the instantaneous rate of change. But you've got to realize that we will try to cover up so that you can't truly see what we're asking for. And that's what makes some of the AP questions kind of difficult, because they're so disguised that you read it and think, I don't even know what they're asking for. Oh, they want the slope of the curve. They want me to find the slope of a line tangent to the curve at a point. Oh, that's just simply the instantaneous rate of change. And of course, to find it, I have to apply this particular equation. This is called the difference quotient. Of the function f at a. So sometimes we'll say, okay, find the instantaneous rate of change using the difference quotient. What's a normal line? Oh, come on, you know what a normal line is. Take a shot. Paxton, I can see you want to say it.
Not really.
Okay, I'll leave you alone then. If I have a line if I want to talk about the normal to that line, I'm simply talking about a line that is perpendicular to that line. That's our definition of a normal. A normal line to a curve at a given point is the line perpendicular to the tangent at that point. Perpendicular meaning, of course, we've got to have perpendicularity. So not only are we going to ask you to find the instantaneous rate of change of a function, and by knowing that, then I can come up with the equation of the tangent line. We might as well throw insult to injury and say, well, after you found the equation of your tangent line, go ahead and give the equation of the line normal to it at that point. So let's put it all together in the following problem. Given that y is equal to 1 over x minus 1, and we are concerned with what's happening at x equal 2, find the slope of that curve for me. Number 2, the equation of the tangent line, and then insult to injury equation of the normal line. First things first, find the slope of the curve. To find the slope of the curve, I have to take the limit as h approaches 0 of f of x plus h minus f of x all over h. And at this problem, we're going to let x equal 2. So, take the limit as x, I always want to use x, h approaches 0 of f of x, now let's do this, f of 2 plus h minus f of 2 all over h. When you study the textbook, and I know that you all do, when you look at a problem such as this, you probably will see them go ahead and simplify this by plugging x plus h into the function minus f of x all over h, simplifying that, and then substituting x equal 2. That's like an added step to me, therefore, that's why I plug in the value for x right away. So, what do we have? I have the limit as h approaches 0 of, well, I'm going to evaluate function f when I let x equal 2 plus h. So I'm going to have 1 over 2 plus h minus 1 minus f of 2, which is 1 over 2 minus 1 all over h. Question?
That limit that you just came up with, 1 over 2 plus h minus 1.
Now this isn't a limit, this is a function value.
Where did that, how did you get that?
This reads, evaluate function f when you let x equal 2 plus h. So here's your function f. I'm going to substitute 2 plus h in for the variable x. So it gives me 1 over 2 plus h, or yeah, 2 plus h minus the 1. And then I had to substitute 2 in here, right? Minus f of 2. 1 over 2 minus 1. And then in your denominator, you've got h, which we're going to allow to get smaller, smaller, smaller. All over the product of the denominators, all over that denominator. It's like we did in pre-cal last year with those lovely trigonometric identity problems. Well, 1 minus 1 is 0, so that gives me negative h over h times h plus 1, which gives me the limit as h approaches 0 of negative 1 over h plus 1. Direct substitution work for finding that limit? Oh yeah. What's my slope of the curve?
-1.
What's another interpretation of the slope of the curve is equal to a -1? Another interpretation. How else can I say that? What did we just do? No, we didn't do that. I'm lost. Did we not find the slope of the tangent line at the point x equal 2? That's exactly what we did. We just didn't say that. We said, okay, find the slope of the curve. But you're finding the slope of a line tangent to that curve at that point. So, done. Write the equation of the line that is tangent to the curve at that point. Okay, I got the slope. I got the x coordinate. So I got to think to myself, if x is equal to 2, or when x is equal to 2, what's your corresponding value of y? 1. So I've got a slope of -1, and I have the point 2 comma 1. Write the equation of a line that passes through that given point that has that given slope. So you're simply going to take y minus 1 equals a negative 1 times x minus 2. Again, don't simplify that. Done. Third thing, now write the equation of a line that is normal to that tangent line. And in order for this line to be normal to this tangent line, it has simply got to be perpendicular. Okay, let's go back to algebra class. We know that the slope of two lines that are parallel is what? The same. What about our definition for perpendicular lines? What about their slope? And don't give me negative reciprocal.
That.
Two lines are said to be parallel if and only, or two lines are said to be perpendicular if and only if the product of their slopes is equal to a negative 1. Now please note my point has not changed. I'm still passing through the point 2 comma 1. The only thing that has changed now is my slope. So for the normal, I have the point 2 comma 1 with a slope. Well, if the slope of my given line is negative 1, what is the slope of a line perpendicular to it?
1.
A positive 1, because the product of negative 1 times 1 is a negative 1. Definition of perpendicular lines. So I've got y minus 1 equals x minus 2. Stop right there. If you want to put that slope in there as a 1, that's fine too. That doesn't hurt a thing. So just pay attention to the instructions in the problem. Sometimes we'll simply ask you, what is the equation for the line that is tangent to the curve? Sometimes we'll ask for the tangent line and the normal line. Remember that the function y equals 16t squared is an object's position function. Again, we looked at this the other day too. Y equals 16t squared. As the object's average speed along a coordinate axis for a given period of time is the average rate of change of its position. Its instantaneous speed, its instantaneous rate of change at any time t is the instantaneous rate of change of the position with respect to time. And because we are looking with respect to time, and we are looking at an actual situation, we alter our slope of the curve as the following. The limit as h approaches 0 of f of t plus h minus f of t all over h. The t represents time, okay? Now if you use x's instead because you don't want to confuse yourself, that doesn't hurt a thing. It does not hurt a thing. The equation for free fall at the surface of Mars is given as s equal 1.86 t squared meters, where t is in seconds. Assume that we drop a rock up on Mars. We drop a rock from the top of a 200-meter cliff. I want to find at exactly 1 second. I don't see anything about slope of a tangent line or slope of a curve. I don't see anything about the instantaneous rate of change. I just want to find the speed of the rock. And again, here we have disguised a problem that is simply an instantaneous rate of change problem. So using this as my model, I'm going to change it to the limit as h approaches 0 of f of 1 plus h minus f of 1 all over h. And again, we give you that function. So I've got to take the limit as h approaches 0. If I substitute 1 plus h in for t, I'm going to get 1.86 times 1 plus h quantity squared minus 1.86 times 1 squared all over h. There is my f of 1 plus t. There is my f of t. So I have the limit as h approaches 0, 1.86 times 1 2h, h squared, minus 1.86 all over h. Distributing, getting rid of my parentheses in this expression, my difference quotient. I have 1.86 plus 3.72h plus 1.86h squared minus 1.86 all over h. .86 minus 1.86, it's gone. So we'll take the limit as h approaches 0. I don't know if you've caught on yet, but in every one of these problems, you got to be able to factor an h out of the numerator so it'll cancel with the denominator so that you can then find your limit. If you can't do that, you've made a mistake. You might as well stop right there, go back through the problem, and find your error. But we're good. I got a common factor of h that I'm going to take out, which leaves me a 3.72 plus 1.86h all over h. Now I can take the limit as I allow h to approach 0. What is the speed of this rock that I dropped when I'm on the planet Mars, 200 meters in the air, after 1 second of fall? What is the speed of that rock? Application problem of instantaneous rate of change. Your homework for Monday will be